Happy spring break, everybody. Gonna get us going here with this presentation. It's gonna sort of lead you through the work for spring break. It'll send you away to do things sometimes and tell you to come back and things like along those lines. You can work through it at your own pace and break it up however you'd like to. All right, to start off with, I gave you the notes and objectives for Unit 12. Go ahead and I suggest that you go ahead and take a moment and just kind of look through all of the different objectives that are in this unit so you can kind of see what's going on. Essentially, this unit combines two things that are related to each other but not directly connected. And one of them is basic things about acids and bases, and the other thing is something about solubility equilibria, or in other words, equilibria that are set up when things dissolve. So to start off, what you're going to do is you're going to go ahead and watch the acid-base notes and know that you're going to need to know the strong acids and bases that are on page 125. I believe they're also in one of the slides in the notes, so you'll be able to know what those are along the way. Okay, so go ahead and spend some time with those notes, and then when you're done, you can come back here. This slide is just to remind you to watch the notes. All right, now that you've done the notes, coming back, we've got a few left sides here for you to do. So here's the first left side. It gives us 3 different chemicals, and it says the above diagrams represent aqueous solutions of acids HX, HY, and HZ with water molecules omitted for clarity. Rank the acids from strongest to weakest. Go ahead and do this left side, and then when you're done, just restart the video. All right, so the strength of an acid is related to its amount that it's dissociated, right? So more dissociation means that it's stronger, less dissociation means that it's weaker. So if I look up here and I look at my 3 different chemicals up here, I see that HY has completely dissociated. Every single particle in there has split apart into ions. So this is going to be my strongest one, okay? Then if I look after that, looks like over here I've got 1, 2, 3, 4, 5. I've got 6 particles that have dissociated. Over here there's only 4, so this one's going to be second strongest, and then this one will be the weakest of them. Left side number 2, you could write a haiku that describes how an acid or base can be weak but also very soluble. I wish we were in class today so that you could share these. Okay, so again here, you can dissolve a lot of the chemical in water, but if it doesn't break down into its ions, then it is a weak acid or base, but it dissolves a lot, so that would make it very soluble. Well, this is actually a pretty easy haiku for me to read. So we go, dissolves very well without dissociation, weak but soluble. Nice job, Mr. Murray. All right, the next one is asking you to figure out the conjugate bases of a bunch of chemicals that have been written here and a bunch of conjugate acids for those that have been written there. Go ahead and take a moment and write down those conjugate bases or conjugate acids. If you want to just do a couple from each line, that's perfectly fine. Come back here when you're done. All right, so conjugate bases are related to their acids by removal of one proton. So if I take away that, I get the ClO minus ion. If I take away one hydrogen there, I get the HS minus ion. If I take away a hydrogen here, I get PH3, okay, no longer positively charged. And last one here, if I take away the H, I get CO3, and that would be CO3 2 minus. Conjugate acids, we're going to add a hydrogen. So again, this one would become HCN, HSO4 minus, H3O plus, and H2CO3. And that charge would go away. Those are my conjugates. All right, the next left side asks, which side of the equilibrium is favored? Take a moment, think about it, and then come on back. All right, so in terms of equilibrium favors going from the transferring the proton from the stronger acid to the stronger base. So if I'm looking in here, I can identify that this is an acid and this is an acid. This is a base and this is a base. All right, and so if I go up here and I take a look at them, we see that water is weaker than CH3COOH. So this is a stronger base, and this is a weaker base. Okay, and then on the other part of it, H3O is a stronger acid than CH3COOH, or acetic acid. And so we're going to go ahead, and there's my strong acid, weaker acid. So the transfer is going to be from here to here, which means that this reaction is favoring going towards the product, reactants. Without looking, list the strong acids and the strong bases. Okay, here they come, the strong acids. We have hydrochloric, hydrobromic, hydroiodic. Okay, those are all the ones that are halogen based. Then we've got ones that are oxide based, so chloric acid, perchloric acid, nitric, iodic, and the one diatomic, which was sulfuric. In terms of the strong bases, okay, so those are all the group 1 hydroxides, or the alkali metal hydroxides. So that's going to be lithium hydroxide, sodium hydroxide, potassium hydroxide, rubidium hydroxide, cesium hydroxide. There we go. Okay. We don't worry about francium because francium doesn't exist very far out there. How about, and then group 2 ones that start with calcium and go below calcium. So calcium hydroxide, barium hydroxide, strontium hydroxide, and radium hydroxide. All right, so now that we've done those left sides, go ahead and do the summary and questions on the acid base notes. And then your next assignment is to go ahead and read the pH, or watch the pH notes video. And then when you're done with that, come back here and we got some left sides to do for those notes. Just a reminder that you should be watching the pH notes right now. Okay, so now that we understand a little bit more about pH concept, we're going to go ahead and do some left sides. So here's the first one. Which of the following statements about the pH of 0.010 molar HClO4 is correct? Take a moment, come back. All right, so if you took a look at this, you should have answered A. Okay, HClO4 is a strong acid, so that means it's going to be fully dissociated. So that means that the concentration of the OH, of the H ion, is going to be 0.01 molar H plus. Okay, so pH equals negative log of the concentration of that, which would be 0.01. And so that would give us 2. Okay, so another way of saying 0.01 is 1 times 10 to the second, negative second. So there's our answer. Here is left side number 2. They give us the autoionization of water. And they tell us that at 5 degrees Celsius, the K value of Kw is 1.9 times 10 to the negative 15th, and pKw is 14.73. Which of the following is correct for pure water at this temperature? Take a moment and then come back. Okay, so if you answered this one, the correct answer again should be A. Okay, and the reason for that is we have 2 expressions we can write here. H3O plus concentration times OH minus concentration equals the Kw, which is 1.9 times 10 to the negative 15th. And we also have the other expression, which is pKw, which equals 14.73, equals pH plus pOH. Okay, so by process of elimination, we can do this, and we can also just do it directly, right? So if I take a look at the going from the bottom up, if I rearrange this equation, we would see that pOH equals 14.73 minus pH, so that one can't be right. Okay, this one up here, this is giving into these in terms of concentrations, and that should equal 1.9 times 10 to the 15th. They put the p value, pKw value here, so that one's not right. pH equals negative log 1.9 times 10 to the negative 15th. Well, that would be true if the H3O plus was 1.9 times 10 to the 15th, but it's the product of those two together. So that one can't be right. Okay, so how do we get to the top one being correct? Well, if this is pure water, we know that X and Y are the same, right? So H3O plus and OH minus mean the same thing. So we could call them both X, right? So that'd be X and X, okay? And so X squared equals 1.9 times 10 to the 10 to the 5th. Undo the square and we get 1.9 times 10 to the negative 15th there. Okay, X is H3O plus, so that's got to be our right answer. Hey, it's been a little while since without looking. List the strong acids and the strong bases. How'd you do? Hopefully well. All right, so next set of assignments for you. We just did the pH notes, so you can go ahead and do summary and questions on those. Problem set 12A is in Schoology for you to do along with the answers, and then one more set of notes video for you. That would be the solubility, equilibrium notes, and precipitation reactions notes. Go ahead and do those things. When you're done with those assignments, come on back here and continue the video. All right, so you had to do problem set 12A. Please make sure you mark any questions you have on that. We'll go over those on the Tuesday when we get back from spring break. Hopefully you watch the solubility equilibrium notes before you watch this. So let's keep going. All right, so here's a left side on that solubility equilibria and precipitation reaction notes. It says, for which of the following is the KSP value of the ionic compound the largest, and which is the KSP the smallest? Explain your answer. Take a couple minutes and we'll come back. All right, so KSP equals the concentration of ion 1 times the concentration of ion 2. Okay, these are all 1-to-1 as we can see at the bottom where the solid is. Okay, and so what we're doing for KSP is we're going to be figuring those out. So we can just count particles essentially. So in this one, if I call the green one A, we have 3 particles of that. If I call the gray one B, we have 3 particles of that. So the KSP here would be 9 something, right? Over here, I've got 1, 2, 3, 4, 5 of each. So that would be 25. Over here, I've got 2 of each. So that would be 4. So which is the highest KSP value, right? And this one would be the lowest KSP value. Second left side, AgS has a larger molar solubility than CuS, even though Ag2S has the smaller KSP value. Explain how this is possible. Take a few minutes and try that one out. All right, so if we write out the KSPs for both of these, the concentration of Ag squared, all right, because we're going to get 2 Ag plus squared, times the concentration of the S minus 2, okay? For the other one, it's copper times the sulfate, okay? And that's going to be there. All right, so if this thing dissolves, it's possible that, for example, the molar solubility of this substance is 10 to the negative 3rd, whereas this substance, the CuS, would be 10 to the negative 4th. All right, so if that's the case, then who has a larger solubility? Well, 10 to the negative 3rd is bigger than 10 to the negative 4th, so that would be greater. Okay, but if I put those into the expression, this becomes 10 to the negative 3rd squared times 10 to the negative 3rd, which gives me 10 to the negative 27th. Okay, whereas this one would be 10 to the negative 4th times 10 to the negative 4th, and that would be 10 to the negative 16th, okay? So we're going to go ahead and take those two things and look at that. So if that's the case, then the KSP of this is smaller than the KSP of that. All right, so next set of stuff for you. Go ahead and add summary and questions to that third set of notes. And in Schoology, you will find AP Practice Problems 12A on AP Classroom. All right. When you're done with those, come on back here for the last part of the work for spring break. All right, the last part of this work for the spring break is to do a POGIL on fractional precipitation. Obviously, you're going to be doing this by yourself. The answers are posted. If you have friends in our class and you want to work with them, go ahead and do so. But you're going to take a look at the fractional precipitation POGIL and work through it and check it out. All right, so your last assignments then for the spring break will be to finish up that POGIL and to do problem set 12B. We will see you on Tuesday after break.